Hello and welcome to the Statistics for Data Science lecture series. This is a beginner friendly course, so if you have not done any statistics, don't be worried because we will cover everything from scratch. Okay, so let's start the video. So in this video, we'll be discussing the estimates of variability and we'll try to explain it using examples. Location is just one dimension in summarizing a feature. A second dimension, variability, also referred to as dispersion, measures whether the data values are tightly clustered or spread out. So in the last video, we have discussed the estimates of location. There will be a pop-up link at the top right corner of your screen. You can click on that link to watch that video so that you have some understanding about what location estimates are. Okay, so in this video we are going to be discussing variability, which is a measure of how spread out or how tightly clustered our data is. Okay, so now let us look at some of the key terms for variability. At first we have deviation. So deviation is the difference between observed value and the estimate of location, right? So it could be for example, if you have some observation and how far it is from the mean, for example, say, so that would be deviation. Next we have is variance. So variance is a measure of how far a set of numbers is spread out from their average value. Then we have standard deviation, and standard deviation is the square root of the variance. Then we have mean absolute deviation. So the mean absolute deviation is the mean of the absolute value of the deviations from the mean. So suppose we have an observed value of say 30 and the mean is 50. So 30 minus 50 is minus 20, but we are supposed to take the positive value. So we'll have to use modulus, a mathematical operator, which basically turns a negative number into a positive term. Okay, and this repeats for all the data, and then finally you take the mean, which will give us mean absolute deviation. We will look at how to find the mean absolute deviation with examples in this video later on. Next we have is range. So range is the difference between the largest and the smallest value in a data set. So this is very common. This is a very common term that we keep using in our day-to-day lives. Next we have is percentile. So percentile is the value such that p% of the values take on this value or less, and 100 minus p% take on this value or more. So suppose if someone scores a 40 percentile, that means he has scored above 40% of the population, and 60% of the population has scores which is greater than the one who scored 40 percentile. Okay, that's what it means. And interquartile range is the difference between the 75th percentile and the 25th percentile. So now let us look at mean absolute deviation. So this is the formula for finding mean absolute deviation. Mean absolute deviation is equal to 1 upon n summation I equals to 1 to n modulus xi minus mean. Let us now look at an example to see how to calculate the mean absolute deviation. So suppose we have some numbers 2, 3, 5, 7. Okay. So at first what we have to do is we have to calculate the mean. So let us say mean is represented by the letter m. So for mean, we'll just add up the values and divide it by the number of values. So this will give us 2 plus 3 is 5 plus 5, 10, 17 by 4. So 17 by 4 is equal to 4 4 is 16 and 2.5. So it will give us 4.25. Right? Okay. So now we have to find out for I equals to 1 because it our n value would be 4, right? So for x1 we have 2. So these are our x1, x2, x3 and x4, right? So first we have to add this xi. So 2 minus 4.25 plus, this is my modulus sign, then 3 minus 4.25 plus 5 minus 4.25 plus 7 minus 4.25, okay, and this whole divided by 4. So 2 minus 4.25 will give me this is modulus of minus 2.25 plus 3 minus 4.25 will give me minus 1.25 plus 5 minus 4.25 will give me 0.75, and plus 7 minus 4.25 will give me 2.75, okay, and this whole divided by 4. I'll use a different color now. Let's call this, okay. So to a minus 2.25 modulus, if we remove the modulus, we get wait, I'll just have to erase this. So it will be 2.25 plus 1.25 plus 0.75 plus 2.75, and this whole divided by 4. So on adding, we get the value to be equal to this is 7 divided by 4, so this will give us 1.75, okay. So this is the value of mean absolute deviation, and if our mean absolute deviation value is small, that means the data is not that is closely around the mean, okay, it is not far away from the mean value, right? So now let us look at variance. So again, suppose this is the formula to find a variance. The variance is basically summation of xi value, where I goes from 1 to n, then minus the mean value and whole square divided by n. So suppose we have some data, for example 4, 9, 12 and 5, right? So the same thing, what we have to do is find the mean. So the mean value comes out to be 4 plus 9 plus 12 plus 5 divided by 4, that gives us 7.5, okay. And now we have to, what we have to do is we have to take the like from each term we subtract the mean and then take the square root and then add up, okay. So like this, and 12 minus 7.5 whole square plus 5 minus 7.5 whole square whole divided by 4. So this will give us how much? Let's check. So this comes out to be equal to 10.25, okay. So this is how we find the variance. Next we'll look at standard deviation. So suppose this this right here we calculated the variance, right, for the values 4, 9, 12 and 5. Say for example we have 4, 9, 12 and 5. The variance value was equal to 10.25. So the standard deviation will be equal to under root of 10.25. So that will give us 3.201, okay. So a variance is used to measure how far the data values are dispersed from the mean, and a standard deviation is used to calculate the amount of dispersion of the given set of values, okay. Standard deviation is derived from variance, as you can see, and tells us how far each value lies from the mean, okay. So and standard deviation is expressed in the same units as the data values. Variance is expressed in much larger units, that is the square of the unit of the data values. So since the units of variance are much larger than those of a typical value of a dataset, it's harder to interpret the variance number intuitively. That's why standard deviation is often preferred as a main measure of variability. Okay, so next we have estimates based on percentile. So statistics based on sorted data are referred to as order statistics. The most basic measure is the range, which is nothing but the difference between the largest and the smallest number. The minimum and maximum values themselves are useful to know and helpful in identifying outliers, but the range is extremely sensitive to outliers and not very useful as a general measure of dispersion in the data. To avoid the sensitivity to outliers, we can look at the range of the data after dropping values from each end. Formally, these types of estimates are based on differences between percentiles. So, in a dataset, the pth percentile is a value such that at least p% of the values take on this value or less, and at least 100 minus p% of the values take on this value or more. So, for example, to find the 68th percentile, first what you do is sort the data, then starting with the smallest value, proceed to 60% of the way to the largest value. Okay, so that will give us 60 percentile. So now I'll open the Jupyter Notebook and see how we can calculate these statistical measures using the libraries available to us. So I have opened my Jupyter Notebook, and at first we will import the required libraries. Okay, so this is a comment, and this is used to make our this is like an annotation, okay, that you write in your source code, which can be read by programmers to understand what your code actually does, right? So now we'll import pandas as pd, as is basically an alias to shorten things. Just call it, you can call it anything, but this is the standard naming nomenclature that we use. Next, what we do is, I have a CSV file, so what I'll do is I will read that CSV file using read CSV, and then pass on the name of the CSV file and then print it out. So this is what my CSV file data contains. So we have like players and their scores. So suppose, let us now first calculate the mean of the scores. Okay, so to do that, we can do it using either by exclusively adding things up and then dividing it by the number of players, or you can just use an inbuilt function in the numpy library called mean, and then just pass on the data which needs to be used to sort of calculate the mean. So from the data frame, we considered the values in the score column. This basically means that, and we then use the mean function, which is in the numpy library, to calculate our mean. So 22.4 is our mean value. Next, we can calculate the variance. So to do that, we can again use an inbuilt function called var in numpy library and pass on the data, which is score. So this is our variance. Okay, and finally, to calculate the standard deviation, you can import the math library. Okay, and then suppose you save this in a variable named variance. Okay, and you just Okay, you just print it out, and then you using the math library, what you can do is we can standard deviation, we can call like create a variable name as the, and then using the math module, use these, because the square root of variance is basically the standard deviation, so we can do the square root of variance, right? And then if you print out the standard deviation, this is the standard deviation value. Okay, but you can also, what you can do is you can also use the built-in std function, which is used to calculate the standard deviation. So as you can see, both days gives us the standard deviation values of the data that is present in the score column. So this is it for this video. In the next video, we'll be looking at the different data distribution systems. We'll look at box plots, frequency table, histograms, density plots, etc. So if you found this video helpful, please give it a like. Do subscribe to my channel and hit that bell icon to never miss an upload. So I'll end this video now, and I hope to see you guys very soon. Thank you.